So it is clear that the pH itself here is equals this is the bar of the constant 6.1 plus the logarithm of bicarbonate over carbonic acids. When we come to analyze bicarbonate, you'll find that bicarbonate is the result of strong ion difference or equal strong ion difference minus total weak acids. We're going to talk about it. So the pH is determined by these strong ion differences we have mentioned before, and we're going to discuss it in details, and the total weak acids, which is the the protein and the inorganic phosphates and partial pressure of carbon dioxide. And these items, strong ion difference, total weak acids, and at the same time the carbon dioxide are called, according to the Stewart, these are independent factors. And these independent factors, but bicarbonate and hydrogen ion are dependent factors. And that's why when we study the ABG, we have to look at all these items. Hydrogen ion, sure, bicarbonate as independent factors, but as dependent factors, but these independent factors should be studied well. Strong and difference to total weak acids and carbon dioxide. When you look at the hydrogen ion, so the hydrogen is the end product of the relation between the carbon dioxide and bicarbonate according to the Stewart. So decrease in the hydrogen ion should look at that. Decrease in the hydrogen ion, this means that there's some sort of increase in the bicarbonate. Increase in the bicarbonate may be primary, or increase in the bicarbonate may be secondary to the increase in the carbon dioxide, partial pressure of carbon dioxide. So when you look at the alkalosis primary or secondary, this is a primary increase in the bicarbonate or second increase of due to increase in the carbon dioxide. Acidosis increase hydrogen ion. This may be due to decrease in the bicarbonate, or the decrease in the bicarbonate may be due to some sort of compensatory mechanism to the decrease in the carbon dioxide. So this is the problem when you look at the hydrogen ion. Again, when we look at the hydrogen, the partial pressure of carbon dioxide, it's a relation to hydrogen ion and bicarbonate as we have mentioned before. To conclude that the partial pressure of carbon dioxide, when you look at it, and the change, is it primary or is it secondary? And the carbon dioxide, when it increases, stimulates the carbonic anhydrase. This will be associated with the increase in the bicarbonate, and concomitantly there will be drop or decrease in the chloride. This is in a problem what we call normal anion gap. So increasing the carbon dioxide will be associated with increase in the bicarbonate and decrease in the chloride, and the two together will be 130. And at the same time, also decrease in the carbon dioxide will be associated with decrease in the bicarbonate and increase in the carb and the chloride, and the two together will be 130. This is a normal anion gap change, so just to be considered. And when you look at the carbon dioxide, you have to look at the oxygen, and if there is some sort of hypoxia, and this is look at the alveolar arterial gradient, is it normal or abnormal, and accordingly you can interpret the carbon dioxide, is it carbon dioxide washed out retention or washed out with normoxia or with hypoxia, and this should be make you to reach to the diagnosis. In addition to this, the relationship between carbon dioxide and pH, carbon dioxide and bicarbonate, and this is the conclusion, and thank you very much.